All right, we are going to start talking today by looking at this magnificent creature here. This is Amadeo Avogadro. That's right. You've heard of him. You've now seen him. Maybe you've never heard of him before, but his name is Amadeo, which apparently at the time that he lived was a very common Italian name, Avogadro. And I should give him full credit. It's not very nice to leave out the fact that he was a rich dude, so he's actually a count. So he is Count Amadeo Avogadro. Avogadro started off life as a rich person, of course, and so in Italy at the time he was living, if you were rich, you went into law, and that's what he did. He became a lawyer. At age 20, he actually graduated from college, and he went to become a lawyer. It didn't take him too long to start to get bored with that, about 5 or 6 years by my reckoning, and it's kind of difficult to be a lawyer at that time in Italy, so he decided to be a scientist. Chemistry was all the rage, and he technically started thinking about, and started experimenting with chemistry. And he came up with a concept. He came up with the mole. The mole. And in chemistry, when we talk about a mole, we're not talking about like a beauty mark that you might find a mole on somebody's face. We don't talk about that creature that, burrows under the ground, has whiskers, has button nose, has the paws with the really long claws on it. No, we don't talk about any of that stuff. When we talk about the mole in chemistry, sorry, Amadeo, let me undeface you, your photo there. When we talk about the mole, we are talking about a unit of measurement. And Amadeo was the first person to come up with this idea. The mole in chemistry actually means an amount, right? And so it is amount of substance present. So in chemistry, we need a unit that we use to say, hey, we have this amount present. And it's different from grams, right, which is mass. It's different from volume or liters, right? Those both tell us something different, right? Mass is how it's going to interact with the earth, and volume is how much space it takes up. We're not really interested in those things. We as chemists are interested in the amount of substance present. Now, we've been balancing equations, and of course, amount has to relate to that. We also don't like to write out that whole thing, and so we write an abbreviation for the mole. It is abbreviated as MOL. Literally, the abbreviation for the mole is we just drop the E off of it. It's the best we could come up with. Sorry. ML was already milliliters, so we couldn't do that. So the mole, the amount of substance present, it's abbreviated as MOL. Avogadro actually gave a definition for it back in his day. But that definition we don't use anymore. We use a different definition of it. And our modern day definition of the mole, is it's the number of atoms in 12.0000 grams of carbon 12, which is awesome. So you can see, as chemists, what we're going to do is we're going to take and we're going to relate the number of grams of a substance back to how many atoms are present. And that is fantastic. Stellar. That is awesome for us. Now, Avogadro didn't use this number. He didn't use this substance. He had a different way of defining his definition. We just need to know the modern day definition. And what is that number? That number is the same for every single substance. I need a little more room here, and it won't let me move the screen around. All right, I think I've fixed it. So to move it around just a little bit, what is that number? Well, that number we call, in honor of Amadeo there, we call it Avogadro's number. And it is the number of atoms in a sample of carbon-12 that masses 12.00 grams. Avogadro's number was calculated actually by Avogadro, but we've since recalculated, we've since recounted it. Nobody counts this number, and we'll talk about that in just a second. It's a huge number, okay? I'm going to write it down in two different formats. The first format is the long way. You may pick whichever format you wish to write it down in. That is a 6022 followed by 20 zeros. I'll put the commas in here. Nobody writes it out this long, though. Avogadro's actual number is written as 6.022 times 10 to the 23rd. And today, the day that I'm recording this, happens to be October 23rd, which happens to be called Mole Day in honor of this number right here. That's right, it is Mole Day. Happy Mole Day, everybody. Enjoy yourself a nice treat on Mole Day. If you're watching this after October 23rd, no treat for you. All right, so that is Avogadro's number. It's a huge number, and the reason it is a huge number is because atoms are so teeny tiny small. We need a large number to be able to get enough of them to be able to mass. Now, 12.00 grams, sorry, left out 2 zeros there. That many grams is about 4 pennies worth of mass. So if you had 4 pennies in your hand, that's pretty close. They're actually going to be, this much carbon is going to take up a little more space, but 4 pennies is this number, Avogadro's number, right? It's crazy. It's crazy to think how large this number is. How big is it, you ask? Well, if you had this many sheets of paper, they would reach from here to the sun 1,000,000 times. If you had that many grains of sand, it would cover the state of Tennessee like 5 miles deep. If you had that many moles, you would look at it and you say, that's not a moon, because it would be 8 times the size of our moon. A mole of moles, Avogadro's number of moles, would be a lump that is 8 times the size of the moon. If you had that many pennies, you could pay off the national debt and then give every man, woman, and child in America $1 billion. Crazy, huh? It's a lot of money. It's a lot of zeros. It's a high number. Avogadro's number, very, very large. We're going to be using this number in future calculations. We're going to be adding a few calculations to it. We're going to start with some simple stoichiometry, and then we're going to move to stuff that's a little more complicated. More on that in the next video.